In section 3, we're going to talk about distance between points, and then we're also going to talk about midpoint. So we're going to start with distance. So first we're going to talk about distance on a number line. So if you have a number line and we'll find the distance between 2 points, you can always count. But the other way to do it is if my points P and Q are values A and B, I can do the absolute value of A minus B to figure out their distance. And the reason why we do the absolute value is because distance is always a positive number. It can't be negative. So if for some reason I subtract the bigger number from the smaller, I want to make sure I get a positive number as the answer. And then next we want to talk about distance between 2 points with coordinates x1, y1, and x2, y2. So this formula is given by d equals the square root, and then you have, in parentheses, we have x1 minus x2 squared plus, and then in parentheses, y1 minus y2 squared, all of which is underneath the square root. You can write it as x2 minus x1 and y2 minus y1. In this case, the order of subtraction doesn't matter because we're going to end up squaring the number, and anytime you square a number, whether it's positive or negative, you get a positive number as the result. Let's go ahead and start with some examples. So we want to find the distance between points E and F, where E is at -4, 1, and F is at 3, -1. So I'm basically finding the length of segment EF. Remember, distance is the same thing as length. So because these are coordinates, I'm going to use the distance formula for coordinates. Now, it doesn't matter which point you label as x1, y1, and which point you label as x2, y2. So recall the distance formula that we just wrote down. Now I'm just going to plug in my values. So we have x1, which is -4 minus 3 squared, plus 1 minus -1 squared. So -4 minus 3 is going to give us -7 squared, plus, now when I subtract a negative number, it becomes addition, so we get 1 plus 1, which gives us 2 squared. -7 squared is going to give us positive 49. 2 squared is 4. So we end up with the distance as the square root of 53. And I would much prefer, because the square root of 53 is not a whole number, it is a decimal, that you leave your answer underneath the square root. You do not write the decimal. But I am going to, because the square root of 53, you don't really know what that length is. If you do put it in a calculator, the square root of 53 is approximately 7.28. So the length of that segment is around 7.28. So now we're going to find distance on number lines. So I want to use the number line to find the length of QR. So we can count. That's actually pretty easy with number lines sometimes, but the farther your points get away, the more difficult it is to find their distance. So let's just use the formula. So if I let Q be A and R be B, I do -6 minus -3 in absolute values. So because I'm subtracting a negative, it changes to addition. So -6 plus 3, so we get the absolute value of -3, which is 3. So the distance between Q and R is 3, so the length of that segment. Next, we want to find the length of CD. So if we label C as A and D as B, we have the absolute value of -5 minus 1. -5 minus 1 is -6, so the absolute value of -6, which gives us 6. If you want, you can write it as QR equals, in the previous example, and write CD equals 6 in this one. So now we want to use the number line to find the lengths of AB and CD. So we're going to have used multiple letters. So let's label AA and BB. So the length of AB, we do the absolute value of 2 minus 10. 2 minus 10 is -8, so we get the absolute value of -8. So we end up with AB equals 8. Now we want to find the length of CD. So if we label CC and DD, we do the absolute value of -3 minus 4. -3 minus 4 is -7, so we have the absolute value of -7, and we end up with CD equals 7. So CD has a length of 7. And again, all of these distances were fairly short, so if you wanted to count them to find their lengths, you can, but as I previously said, the longer the segment, the more difficult it can be to just count the ticks on the number line. So now we're going to use the distance formula to find distance between points. So we want to find the distance between point A and B, where A is at 10, -2, and B is at 13, -7. So I'm just going to label the first point A as x1, y1, and then B as x2, y2. So using my distance formula, we have x1, 10, minus x2, 13 squared, plus y1, -2, minus y2, which is -7 squared. 10 minus 13 is -3. So we have -3 squared plus -2 minus a -7 becomes addition. So we get -2 plus 7, which is 5 squared. -3 squared is a positive 9. 5 squared is 25. So we end up with the distance being the square root of 34. Which if we use a calculator, the square root of 34 is about 5.83. Again, I prefer you leave it underneath the square root, but to understand what the square root of 34 actually is, it's nice to know what the decimal is. So next we have x at -5, -7, and y at -10, 7. So x1, y1, x2, y2. So we get the distance equals -5 minus -10 squared plus -7 minus 7 squared. Again, all underneath the square root. Changing the -5 minus a -10 to addition, we get -5 plus 10, which is 5. So we have 5 squared plus -7 minus 7 is -14 squared. 5 squared is 25. -14 squared is 196. So we get the distance equals the square root of 221, which is about 14.87. And then our last example is the distance between G -4, 1 and H at 3, -1. So we have x1, y1, x2, y2. So the distance is going to equal -4 minus 3 squared plus 1 minus -1 squared. Notice how every time I subtract a negative number, I'm putting parentheses around it. That way I remember to include the negative when after the subtraction sign. Because I see a lot of times that when you have to subtract a negative, a lot of people are like, oh, it's negative. I'm just going to write it as 1 minus 1, when really you should remember the negative separate from the subtraction sign. So -4 minus 3 is -7. So we have -7 squared plus 1 minus a -1 turns into addition. So 1 plus 1, which is 2 squared. -7 squared is 49 plus 4. So again, we get the distance of the square root of 53, which we found already to be approximately 7.28. Now we're going to talk about midpoint. So we can have midpoints on line segments on the number line. We can also have midpoints on the coordinate plane. So let's start with what a midpoint is. So the midpoint M of a segment PQ is the point between P and Q such that PM equals MQ. So a midpoint just splits a segment in half. If I have a midpoint, the endpoint to that point on either end is going to be the same. So if we start from the midpoint on a number line, so the coordinate of the midpoint of a line segment whose endpoints have coordinates A and B is going to be this formula right here, A plus B divided by 2. Just add the values on the number line, divide by 2, and you'll get the value that's exactly halfway between those 2 points. So if we take a look at our first example, we have the coordinates on a number line of J and K are -12 and 16 respectively. Find the coordinate of the midpoint of JK. And it says hint, draw a number line. So I'm going to draw a number line. I know I have we have J at -12, and I can draw all of the lines in between. It's going to take a while, and I know K is all the way over here at 16. So I want to figure out exactly where the midpoint is. So if I label J as A and K as B, we're going to do -12 plus 16 divided by 2. -12 plus 16 is 4, so we get 4 divided by 2, which means the midpoint is at 2. So if I had every tick mark, so let's go ahead and see. I don't have enough lines to count by 2s, so add a couple more in here. So -10, -8, -6, -4, -2, 0, 2, 4, 6, 8, 10. I don't have enough lines. So if we did, here would be 2, this would be my midpoint M. Make sure you have enough lines to make sure that you can see exactly that it is halfway on your number line. So we have the coordinates on a number line of T and S are 5 and 8. Find the coordinate of the midpoint of TS. So this is not too difficult to draw because 5 and 8 are very close to each other on a number. So 5, 6, 7, 8. We have T and S, which we can label as A and B. So we do 5 plus 8 divided by 2. 5 plus 8 is 13. Divided by 2. Now 13 divided by 2 is not a whole number, it is 6.5. So my midpoint is going to be halfway between 6 and 7. So here is where M lies. So next we have to talk about how to find a midpoint when we graph on the coordinate plane. So the coordinates of the midpoint of a segment whose endpoints have coordinates x1, y1, and x2, y2 is given by this formula over here. So the x coordinate is found by doing x1 plus x2 divided by 2, and the y coordinate is found by doing y1 plus y2 divided by 2. It's a very similar concept to on a number line where you just add the endpoints, but you have to add the endpoints for each coordinate to get our new coordinate for the midpoint. So when we take a look at example 3, we want to find the coordinates of the midpoint of PQ for point P at -1, 2 and Q at 6, 1. So when we find our midpoint, we're going to do I'm going to label my points x1, y1 and x2, y2. I want to do -1 plus 6 all over 2, comma 2 plus 1 all over 2. -6 plus 1 is going to give us 5 over 2, and 2 plus 1 is going to give us 3 over 2. So my midpoint is at the point 5 halves, 3 halves. I prefer you leave it as a fraction, but if I write it as a decimal, it's the point 2.5 comma 1.5. Both are acceptable, but I prefer you leave the answers as fractions. So look at example 4, we want to find the coordinates of the midpoint of segment GH for G at 8, -6 and H at -14, 12. So I'm labeling my points x1, y1 and x2, y2. The midpoint, if I add my x's, we do 8 plus -14 over 2. And then add my y's, -6 plus 12 over 2. 8 plus a -14 is -6 over 2. And -6 plus 12 is 6 over 2. -6 over 2 is -3. Positive 6 over 2 is 3. So my midpoint is at the point -3, 3. In example 5, we want to find the coordinates of the midpoint of segment AB for A at 4, 2 and B at 8, -6. So again, label points x1, y1, x2, y2. When we add our x's, we get 4 plus 8 over 2, and then our y's are 2 plus -6 over 2. 4 plus 8 is 12, so we get 12 over 2. 2 plus -6 is -4 over 2. So we get a midpoint at 6, -2. So our last example says, what is the measure of segment PR if Q is the midpoint of the segment? So if a point is a midpoint, it means that it splits the segment in half. So I know that PQ and QR are going to be congruent. So when I go to find the length of PR, I need to find X. And since I only know the length of QR, but I know that PQ is also the same length, I can say 6 minus 3X plus 6 minus 3X is going to equal the length of my whole segment, 14X plus 2. Because Q is the midpoint, I know PQ and QR have to have that same length. So combining like terms on my left side, 6 plus 6 is 12. -3x minus 3x is going to give us -6x. So we have 12 minus 6x equals 14x plus 2. I'm going to go ahead and add 6x to both sides. So we get 12 equals 20x plus 2. Going to subtract 2, so we get 10 equals 20x. And to finish solving for x, we're going to divide by 20. So we get that x equals 10 divided by 20 is 1/2. So we get that x equals 1/2. But I'm not done solving because I wanted to find the measure of PR. So to find the measure of PR, I'm going to plug in 1/2 for x. So we get 14 times 1/2 plus 2. And I did leave x as a fraction because it actually works easier when I plug it in for x if I leave it as a fraction. Because 14 divided by 2 is 7, so 14 times 1/2 is going to give 7 plus 2. So I get that PR has a length of 9. So this leads us into our last definition that says about a segment bisector. So any segment line or plane that intersects a segment at its midpoint. So if we look at our segment XY, we have a line going through point M, and we're going to call that line going through point M the segment bisector. So that means M is the midpoint, which means it creates two congruent segments. So I know the segment XM is congruent to segment YM. I also know their lengths are the same. So I can also say that the length of XM has to equal the length of YM. So as you're working on the assignment, if you have any questions about distance or midpoint, please let me know.